let's start. So today we are going to finish the chapter 7 that we couldn't finish the deadlock the management. So using the banker's algorithm, we can solve the problem of the deadlock. For the deadlock, the prevention avoidance was the first to occur. Then today we are going to see the deadlock detection. So then I think that pretty much we can finish the chapter 7. Then we are going to skip the 8 and 9 for the second project. So second project is to develop your file system. So we'd better talk about the chapter 10 through the 13 first, then go back to the 8 and 9 at the end of the semester. Then pretty much we can finish the most of chapter that we planned. If we have a time at the end of the semester, hopefully, I'd like to introduce a couple of topics that are interesting nowadays, like the blockchain and the others. So then we will have the final exam. Also, I think that you can submit the homework that I assigned last week. So regarding to, I'm going to quickly review again the banker's algorithm. Then if you do not submit yet, so why don't you submit before you leave the class today? Okay. And also to make up your midterm, so it's optional to if you want to make up your midterm. So if you implement the real-time operating system, did I decide the due date? So by this Friday, okay, why don't you set up the time to demonstrate, and why don't you create the canvas to submit there. By the Friday, if you implement the real-time operating system, don't have to implement the graphical user interface or whatever, you can just print out, okay, using any the program language, the real-time operating system. So what I want to see from your makeup, the assignment is whether you are understanding the real-time scheduling algorithm. So if you understand, you can quickly implement. Don't worry about the graphical user interface. Just focusing on the algorithm itself. So you can use the same process state. It's just a two-process case. But if you want, you can add more. So then directly submit to the campus. If you are done, then demonstrate. Because at this time you can use any program languages. Some of the programming environment cannot be executable by the GA. So why don't you submit? Then set up the. Why don't you announce for the schedule on Friday? Then you can demonstrate. Any question regarding to the schedule?
So that's for the two on the last page of the exam, or what?
The last one, the real time.
There's two of them.
Yeah, scheduling algorithm.
Yeah, can we have a copy of that?
Oh yeah, okay. That's the exactly same as the textbook. Okay, exactly. And also same as the PPT file. Even I didn't change the process state, but if you want, I can upload to the campus after the class.
We gave the exam back to you.
Oh yeah, you gave me.
Yeah.
I didn't update yet, so because some of the students didn't check the exam score, so probably but I will post because several the makeup exam they didn't take the test this one, so I will update. Okay, and but you don't have to wait. The question is exactly same as the textbook as well as our present lecture note. Any questions? Don't worry about the fancy nice interface, just focusing on the algorithm, whether you are able to implement the algorithm, you are understanding the algorithm, real-time the scheduling algorithm. Okay, so we have talked about the deadlock. So deadlock has the full requirement, mutual exclusion, hold and wait, no preemption, and circular wait. So if we have the certain situation like that satisfied with these four conditions, then we can say that is a deadlock. But to understand the deadlock, we adapt the idea of the graph structure. So we talk about the resource allocation graph, RAG. But RAG usually used for the image processing. So it's a region adjacency graph, or in the social media, the data structure we use such the RAG, but in operating system we use resource allocation graph. So there are two types of the node. Like the one is the process, another one is the resource type. So resource type is may have the several instances. Then there are two types of the edges. One is request, another one is assign. So this one is requesting. So using the resource allocation graph, our goal is to find the circle or not. If we can find the circle, that means it may be deadlock. Not always, as we have seen before. Not always, but conventional way, we consider such the state as an unsafe state, then there's a possibility deadlock. We need to do something. Otherwise, if we cannot find such the circle, it is a safe state and no deadlock. Okay. Then we have the in this chapter we are going to talk about totally four different approaches to address the problem of the deadlock. First two approach is never ever enter deadlock situation. The first one is the deadlock prevention. Prevent means why not? The breaking one of the requirements from the four: mutual exclusion, hold and wait, no preemption, and the circular wait. Why don't we break at least one of them? That means no deadlock situation. But as we discussed before, it's not sometimes possible. Like for example, no preemption. Can we make all the research preemptive? No, it's not. The ones that start, then it should be done sometimes. Okay. Circular wait, it's not easy to make the serial using using the serial sequence using of the research. So we need to. So sometimes it can be waiting. So deadlock prevention sometimes is not always possible, but and in certain case, certain operating system, it may be possible. The second approach is the deadlock avoidance. So if using the resource allocation graph, so then applying the banker's algorithm. So if there is a request, then check whether this one has a circular wait or not using banker's algorithm. Idea of a banker's algorithm is like that, as if you are a banker. So you should be able to pay back for any customer. So but you don't want to keep all the resource ready. Instead, if you are vendor, if somebody lend your resource and get back and assign, give back to your customer who requests the money, like that. Okay, that is a banker's algorithm. It's a simple algorithm to understand. Concept is simple. So it's a deadlock prevention, then the deadlock. Yes, so this is a banker's algorithm based on the safety algorithm, same meaning. So banker's algorithm is based on the safety algorithm. So where is that algorithm? This one. So first time, it's not easy to intuitively understand this safety algorithm like this one, but using the example, you can easily understand the safety algorithm. So last time we have seen this. It's allocation max available for 5 processes. So far there are 10A, 5B, and 7C the research, but it's 2P0 need 7A, 5B, 3C to be terminated. But currently the P0 is using 1B only, like that. Okay. Then if these are the allocated resources, if you sum up, then the substitute from this one, you will get how many available. Okay. In other words, the to be terminated, for example P0, P0 needs 7 more A, 4 more B, the 3 more C. That is the need. And consequently, we can actually find how many resources are needed to be terminated. Please pay attention to this one. So instead of late homework, so this is the need. Okay, then our goal is whether we can find the list of the sequence, process sequence. So, for example, how can we do that? Using this one, we need to find need and P0, 1, 2, 3, 4. And the substitute max minus allocation. So 7, 4, 3, and then we have 1, 2, 2, 6, 0, 0, 0, 1, 1, and 4, 3, 1. Then available is currently the 3, 3, 2 resources are available. The safety algorithm is simple. So can you find any process their need is equal or less than available? So this one is not possible. This one is yes. This is not possible. This one is yes. This is not possible. So first candidate is either P1 and P3. So let's select the P1. So once P1 is done, the P1 are before the terminate. So 1, 2, 2. So minus 1, 2, 2 is 2, 1, 0. So currently available is 2, 1, 0. No more need. Then the P1 return 3, 2, 2. So once P1 is done, 3, 2, 2 will be returned. So that is a 5, 3, 2. So P1 is done and the currently available is 5, 3, 2. The next one, we are going to find the process that are equal or less than available for all each resource type. So this one is not possible, this one is not possible. Yes, this one is possible. So P3, let's select the P3. Then the 0, 1, 1 minus 0, 1, 1 and 5, 2, 1 is currently available. Then no more need the P3. So once P3 is done, the max 2, 2, 2 will be returned. So plus 2, 2, 2. So 7, 4, 3 are available. So P3 is done. Then keep going. Which process are equal or less than this one? All of them. So P0, P2, the P4. At least one. So it may be different in your homework, in your answer, and in yours. It may be different as long as you can find at least one exit. Even though there are multiple exits in this room, in case of fire, you can use at least one of them. You don't have to use all the door. Okay? At least one, so then we can get out of the deadlock. So this is not this is a safe state. Safe state means no deadlock. So no deadlock means so you can accept, okay, the request, okay, like this. So this is the deadlock avoidance. So in case of if you cannot find such a list, then this is non-safe state. It may be the deadlock, not always, but we consider this may cause the deadlock, so decline the request. That's the idea of the deadlock. So then, any question so far? So this is the Ranker's algorithm using the resource allocation graph. Okay.
Professor?
Yes.
I kind of have a question.
Yes.
It's more so about, not specifically what about the mini assignment, but you know when it says, can the resource be allocated, or does it mean completed?
You mean the mini assignment is the classroom homework?
I finished it.
So
but
we are going to go for that.
Okay, I just
Yeah.
want to clarify.
Yes.
because I'm
So then
confused.
this is the example of the algorithm. I think that we did this one.
Yeah.
Okay. And what about this?
So this 330.2, is it the allocation
Yes.
or it's the need, or that's what's confusing?
So last time we finished the class with this P1 request 102. But that was okay because we can find at least one the sequence. Let's do this one. The 330 by the P4. P4 request 330. So we need to go back to the process state. The process state is for the allocation and the max and the need and the available. So P0, 1, 2, 3, 4, 0, 1, 0, 2, 0, 0, 3, 4, 2, 2, 1, 1, 0, 0, 2. So 7, 5, 3, 3, 2, 2, 9, 0, 2, 2, 2, 2, 0, 3, 3. And the need is the max minus the allocation, that is 743, 122, 600, 0, 11, 431. Then the available is 332. It's a current state.
Yeah, that
Okay, then
makes sense.
if the P4 request 330, so it need it's not the current state. The P4 need maximum this amount of resource, right? Currently, it has only 2 of C. Okay, then 3 more A and 3 more the B is requested. Then check whether if operating system accept this request, whether this is the deadlock or not. We need to check. Okay, then which means suppose that we accept such a request, which means 332 is allocated. Suppose that. Okay, then maximum is not changing. Then need is we already allocate. Then it need 1 more A, 1 more C is needed, and also 330 is allocated. It's not the accept, but suppose that if we accept such a request, whether this may cause the deadlock or not.
So you,
Then we can check this
yeah.
safe or non-safe using banker's algorithm. How can we do that? So need is equal or less than this. Any process?
Nope.
No. This is not. That's it.
Okay.
No
so you,
process. So what the operating system can do? Decline this request because this may cause the deadlock. Similarly, so 020 we can check such a thing. So that is the deadlock prevention. We can prevent the deadlock. Okay. Any question? This is your homework. Okay. Then the last one is a deadlock detection. The deadlock detection is we allow always because before we allocate or the decline, operating system need to check every time. So for example, if you guys are doing the homework or the by project, you always get my permission. So instructor check every time before I approve or the decline your request. It takes a time. So the last approach is we just allow, operating system just allow the every request. Okay? Then periodically, every the period, the operating system check whether this condition, this process and the resource state is the deadlock or not. In other words, safe or non-safe using the same banker's algorithm. There's no difference. But the only difference is whether operating system, how often when operating system check the deadlock or not. So, for example, this is a current process state. using the resource allocation graph. Is this the deadlock or not? Eventually P5 will be done. Okay, then release this one. Then the P2 request the P2 get the R3. And also R4 is held by P3 and request the R5, but it's held by P4 and R2, P1 and the circle, so it's a deadlock. Okay, we try to find such a circular way. If yes, then the operating system declare this is the deadlock. Okay. Or what about this? We can simplify this problem like this. Okay. So how can we do that? Exactly the same thing. Using the banker's algorithm. So banker's algorithm, we can this detection algorithm exactly same as the banker's the safety algorithm. So using the same algorithm, so we have the allocation and the request and available. We can use the same banker's algorithm. So let's start with P2. Which one can be done? This one, the P0 and the P1, P2, P0 and P2, they do not have any further resource, right? So it's a 0, 0, 0. So P0 and P2 can be eventually terminated. So P0 and the P2 will be eventually terminated. What happens when they terminated? When they are done, they will return allocated resource. So allocate the resource P0, 0, 1, 0. P2 is 3, 0, 3. Total 3, 1, 3 will be added to the available. That is 3, 1, 3 available. Okay? Then each one is equal to the other. The P1, P3, P4, they are equal or less than the available. So P1, P3, P4 will be terminated in this sequence. So which means what? There is no deadlock. Okay, it's a safe state. There is no deadlock, so the operating system can move forward the next step. Then periodically, like the 10 milliseconds later or the 1 second later, operating system can check the entire state again, whether there is a circular way, whether it is the safe state or non-safe state, using same algorithm. Okay. The only difference from the deadlock avoidance is the avoidance is check the request. What if I accept this request? Then whether it's a deadlock or not. In case of deadlock, decline. Otherwise, the accept, safe state accept. This deadlock, the detection is we allow any request. Then check whether periodically checked whether there exists the deadlock or not. Okay, that's the only difference. The algorithm itself is we are using only banker's algorithm, safety algorithm. Okay, that's the only difference. Okay, so deadlock. What if we detect the deadlock? Yeah, we need to do something. Operating system need to do something. Any solution? So if you remember the first slide of this chapter, I showed the traffic in the junction area. So what can be the solution?
You have to stop everything and fix
We can bomb everything. That can be one solution. We need to find the process forcibly terminate. Otherwise, no other solution. Because not many of the resource, because the resource type is already decided. It's a shareable resource or non-shareable resource. Because of non-shareable resource, we get the deadlock problem. So, solution, we need to find the victim, the process. We need to decide the process to be terminated.
But then if the system is deadlocked, how can you then run another algorithm if
then, that is the next step.
Like,
yes. So how can we decide?
It's like we have a car that runs out of gas.
Yeah.
How can you drive that
We need
car
to
fix
find
something,
the cheapest car. old car, like that. Yes, that works. So when we decide the victim, we can consider such a priority. And we can consider depending on what is the priority. For example, really, in the CPU scheduling, we have seen many of the operating systems, including Windows, use the priority number, nice number. Okay, it's the same thing. Nice number, priority number is the same thing. So we will keep the highest priority process. That means we will keep the lowest priority the process to solve the deadlock. Or it's all of them are the same the criteria. It's a priority. Depending on what is a priority. Long running process. Okay, it's a highest priority, and which means the late arrival time will be terminated. So research, how much use? If we forcibly terminate, kill the process that use a lot of research, it will take longer time if we restart later. So we can consider research and the others. Okay. So this is a priority-based problem. A certain process can be forcibly terminated again and again, which is called what? Starvation problem. So starvation problem is always the problem of what? Priority-based. Any priority-based algorithm has the same problem. So do you remember how we can address the priority-based algorithms to avoid the starvation? It's a promote. It's called the AD. So if a certain time or the number of the terminate, then we can promote. Eventually, it will get the research, or it will not be selected as the victim one. Okay? So minimizer. This is our goal. To find the victim, the process, the minimize. Okay? So real solution. So we usually combine deadlock prevention, deadlock avoidance, even the deadlock detection. Okay? Then, as you may realize, I emphasize on the graph theory in this chapter. Graph theory looks nice because it can keep, unlike the other data structure, like the linked list or stack and the queue, and unlike the simple but fast the data structure, graph structure can keep the relationship between the data node. Okay, so for example, if you think about the Facebook, so we can actually keep the relationship between two Facebook users using what? How many times they like each other, or how many times the post and the invite and something like that. So we can keep such a relationship. Problem is mostly NP hard problem. It takes a long time. It's a high complexity. So if we run such a banker's algorithm to find the safe or non-safe state, how long it takes? It takes a really long time. Okay? Even how to decide the victim process. So it's not easy. We need to consider the priority different. The criteria, like we can consider arrival time, the priority number, and how much resource we use. So it takes long time. So CPU operating system cannot run the scheduler, init process, kernel process. That means the overall performance will be degraded. So the practical solution of the deadlock management is, I probably mentioned the beginning of this chapter. Practical solution. Ignore. That doesn't mean you can answer the final exam if I give the deadlock detection algorithm. So really happen. One student answer ignore. Really. But practically, so if we implement this one and periodically run the same algorithm deadlock detection, your operating system cannot run properly. So current, but as I said, even though the current modern general purpose operating system ignore the deadlock, however, in the specific purpose or mission critical system, consider such a deadlock management. Also in your programming level, some of the programming level, they actually implement such a deadlock problem, deadlock solution within just like the synchronization problem. Synchronization problem, I never used the synchronization solution, but intuitively, some of the class, in case of Java, is a monitor, so they use their own synchronization solution inside. Similarly, deadlock, the management can be used for such many other applications. So, currently the solution is ignored because it's too expensive. Then, what happens in case of deadlock? That may happen. So, if I have the 30 students in this classroom, so if I'm the really good teacher, so I can manage and take care of all students, the life and out of classroom, the activity, everything, and whether you guys are friendly or whatever. But I cannot do my job, so I usually ignore that. If something happens, you guys will be in charge of that. Okay. Similarly, operating system, in case of the deadlock, so from time to time when you run your program or the software application program or the network, it's not moving forward, then what happens? Control C is the interrupt. So user, the application program is in charge of the deadlock. So Control C is the user created what? Interrupt signal. So you can stop the current state, then the environment, then the context switch, and move to the next one. Or worst case, shut down and start up because of such a case. So I don't think there's a perfect, deadlock-free operating system. They try. Nowadays it's better. Why? Because our resource is more and more, bigger and bigger. That doesn't mean it's deadlock-free. It can be happen. Okay. So because of that, in your application program, sometimes you should manage it by yourself in the application level. So that is the solution, the practical solution of that. Any question before we move to the next chapter? Okay, so then, as I said, we will skip the chapter 8 and 9, the memory management. We will cover after the I/O management. Okay. Also, the chapter 10, 11, 12 are very important for your second project. Okay. So my programming assignment is not the competition of the programming skill. Okay. I usually GA, I mentioned to the GA, and he will not grade your the kind of how much fancy, nice the interface or programming skill. Instead, we focus on whether you guys understand the algorithm, then implement your understanding algorithm with your program language. So this is a typical example. If you do not understand the file system, what is a file system, what is the data structure of file system, so I think that you can be successful. So try to understand first what is the requirement, what is the data structure used in the algorithm used in the file system management before we start. This is the advertisement for what? Hard disk drive. It's how much big? 10 megabyte. It's only 6,000. Wow. It's even 30 years ago. So that means considering the inflation. I think the 6,000 almost yearly salary, I believe. So no more, less than at least 6 months, I believe. Yeah, you don't have to check. But anyway, so this one is much cheaper, for 3,400. So, but it is a real story. Surprisingly, the ad shows what is that inside of a hard disk drive. Anyone who ever opened the hard disk drive? Because it's hard to see. the hard disk drive. Nowadays we are using a lot of the SSD. I'd like to introduce between the SSD and the hard disk drive. But surprisingly, the architecture still used in the hard disk drive. If you are using the hard disk drive, it's exactly the same. So you can see the number of the disk, and each disk has the number of the track. Then the set of same track number is called the cylinder. So when you buy the hard disk drive, you can check how many cylinder. Okay, that determines the capacity. And this is the head. This head is moving forward and backward, and this one is rotate. And finally, we can get the data. And much cheaper is 1,000, less than 1,000. I believe that between this one and this one is 1982-3. At the time, my first personal computer was the Apple II computer. Anyone who ever used old Apple II computer? It's a 16-bit. Probably not. So surprisingly, I still don't understand my dad. The purchase such a very expensive is $2,000 at the time, 1983. When I was 13 to 14, because in my old educational system, the middle school start from the 14 years old. It's a 7th grade. Then at the time he purchased. Probably I believe the dad was a banker, so one of his customers started the business for selling the new device, the new technology computer. So he actually was as the first list to buy that. Then, but anyway, it was really expensive, the toy, because I didn't know how to use such a personal computer. Then I took the lesson from who teach something very basic program language, which is called the GW Basic, and so on. So then I think even though my major was not computer science at the time, I had a little bit the talent because I won the programming competition at the time. Then the prize was really to promote the new. Such an expensive electronic, the toy, they actually award the 1,000. So actually, I compensate half of the price of the personal computer. Then at the time, believe it or not, my programming, the program that I submitted was the exactly same idea only as what is the name of the game? So. Angry Bird. So Angry Bird, actually you can shoot and hit the target. So actually the program was randomly create the mountain using the height and the width. Okay. So I draw the mountain obstacle using the line, 2 lines only. Then there is a cannon. The name was the cannon. Then the user can specify angle. One is the angle. Then another one is the speed. So then this one actually if 2 input are done, then fire, then hit the target other side. So depending on how much close, so give the point. So it's the same idea as Angry Bird. So I should have the business on that.
Come on.
So then that was almost 35 years ago. So 1982 when Steve Jobs released the Apple II. Then it's getting cheaper and cheaper. But think about how we can store the data in this kind of disk. Have you ever used the CD-ROM or CD to listen to the music?
Mm-hmm.
So then, how was the quality? Any difference between listen the music using the CD-ROM or your iPod or iPhone or any other MP3 device? Any difference? Actually, not much difference. The reason is that still many of them, even though we have a bunch of different music files, but it is true, the MP3 format was a kind of ancestor. It's basically very similar. What is the MP3? Anyone who have thought about what does that mean? The MP3, why is only 3? Is there any one version or two version? What does that mean, MP3? Never. MP means it's MPEG. So MPEG means it's a user group who determine the standard of the multimedia data. Multimedia data means image, video, audio, and so on, such a thing. So MPEG. So when you watch the movie, so you can download nowadays MPEG 4. So it was started from the MPEG 1, MPEG 2, actually no MPEG 3. It's not the MPEG 3. MPEG 4, MPEG 8, and the 16. This is the kind of a generation of the MPEG multimedia standard. They focus on the first time compression. The reason is that the image file, video file are too big, considering what? Bandwidth of the network, capacity of the computer system. So what they need is, as you can see, it's very expensive. So to store the MP3 file, right? Maybe two the song. Then we need the 10 megabyte. The hard disk drive is cost the $1,000. It's too expensive. So what we need is the first generation of the such MPEG standard focus on the compression. Then they realized that the video was not the good quality in the first standard. However, they realized that there are different layers of the standard. So when we play the video based on the MPEG, it's not only the video. This is the first layer is the video, is the time. Along the time, they have the multiple layer. Third layer is the audio layer. The layer. So audio is in the third layer of the MPEG. Because of that, it's called the MPEG standard layer 3. It's for audio. Then this audio compression is based on what? It's called the digitizing. What is audio? Basically, analog audio. It's a frequency. It's a wave. It's like a wave. Okay. Then it hit your eardrum. Then people can the vibration and such information go to your brain. Your brain process then understand the audio, music, and so on. However, we cannot keep such analog continuous data in our computer system. Instead, we need to digitize 0 or 1. So how can we do that? We cut discrete along the time. Then this one will be like this. We lose some of the this one. If we digitize into the 10, actually this is like this, but this one is a 10. We lose a little bit information. But once they apply the audio layer compression in MPEG, actually the people cannot realize the difference between analog and the digitized one. So actually our music quality is done long time before, even though there are something other, the file type. It's not because of the quality. It's not because of the space. It's because of the security purpose. Like the Android use prefer the audio type, and the iOS use their own preferred audio type. But in terms of quality, in terms of the compression, it's already done at this time. So they have instead of wave, we have 011, 0011, such a binary data, digitized data. So if we can store such a binary data, any device, we can later listen by playing if we have the music player is not very complicated, not very expensive. Just based on the level, along the time level of the data, and there's a usually specific header frequency of the something the C, D, E, F, G like that. It's easy to display. So how problem is from the computer scientist how we can store this data. Okay, so first time we use for me to store such a data, digitized data on the cassette tape also. Have you ever used the cassette tape to listen to the music? I did a lot.
Yes.
When I was 16, 17, during my teenagers, from the radio station, if there are announced to the pop song or the latest song, then I was ready to record the cassette tape and like that. That is analog. However, if you store this one to the cassette tape, as long as such a cassette, the tape is a magnetic tape. So 0 or 1 you can represent. Still you are using the, what is that? The credit card. Still it has a magnetic tape. We can store the binary data. The 0 or 1, such as the data to the magnetic tape. So you can actually store the data magnetic tape. Then, problem?
Small.
It's not reliable, small and reliable. So heat, and so people think about another way. That is the disk. So this disk is like the disk, you know. Exactly same as any types of the CD-ROM or DVD-ROM. They has a number of track. Okay, then it has divided by the same angle. Then logically they have the number of the block. It's a logical block sequence, LBS. It's a 0, 1, 2. So this block can be, actually it has, if we enlarge the track, then it has a hole or nothing, hole or block. So if we make the hole, this is a 1, the otherwise is a 0. As long as we can represent the binary, 0 or 1, so we can keep the data. Depending on the density, depending on the read-write or not, it can be DVD or the different. Okay? The size of the media. So this is a hard disk drive. So by collecting number of disks, so we can use this disk for hard disk drive. So this is a hard disk drive. It's a storage media. So comparing to the magnetic tape, this one is much bigger and much faster. And also this one, main problem of the magnetic tape is it's not random access. It's a serial access from the beginning to end.
Yeah.
That doesn't mean that we can throw away this one, still use it for what?
Credit card.
Credit card and backup purpose. So we use the small, it's called the LTO, the tape. Sometimes it's called the dot tape. I think before we are using the card, small, the memory card,
yeah.
we have used small, the magnetic tape. So that is for right now used for backup purpose. Chip. Okay. Surprisingly, actually, this one nowadays reliable. So think about your memory stick. Do you think a memory stick is forever? No. It's easily sometimes damaged. So sometimes if you do not have a backup, sometimes the flash drive doesn't work. So it's actually affected by the environment, and also it's not forever. So it is saying that theoretically 100 years, it lasts 100 years, but nobody uses 100 years. So this one magnetic tape is reasonably reliable, actually, if you keep the certain temperature and humidity. However, it's not used for the general purpose of the storage. Then most of them still we are using such a hard disk drive as the main storage hard disk drive. Then we have right now it is cheap, and it's considering the price, it's the very high capacity. And the problem of this one, This one has the what? You have the header, like this one, this guy. This header is moving forward and backward, and also that one, the disk is rotating. So that is the reason when you search the hard disk drive, you need to take a look at what? RPM, rotation per minute. How much fast? Nowadays it's higher than 10,000. Okay, think about the car engine. It's a 2,000, 4,000. I think you maintain 2,000 to the 4,000 RPM for your engine speed. But this one is nowadays is 10,000. That doesn't mean it's always good, because if too fast, okay, so it's energy and it's something other problem. So 10,000 is reasonable for the hard disk drive nowadays. And one more thing is number of cylinder, okay, that determines the capacity. However, if you have too many cylinder, too many tracks, okay, there your head is need to cover too much area, okay. But you can check such a thing. So that is the reason, not just the capacity, like mine is 1 terabyte hard disk drive, but slower than others, okay, because of such a thing. So, but still, main problem of this hard disk drive is it's a mechanic.
Moving part.
Yeah, it's a moving part. That's actually the risky, not only just the speed, but also the durability, okay. It can be, if you hit the drop, so your hard disk drive may be damaged. Also, this surface is getting thinner and sensitive. So main 99.99 damage of your hard disk drive is what? Unfortunately, touch the surface of the disk is called the scratch. If you have such a scratch, so I scratch only the less than 0.001%, but because of this 1 byte of data, your entire file system will be damaged. But there is a way to recover. Yes?
So what about fragmentation? Is that more so?
Fragmentation is
because
logical
of the
problem.
user, right?
Yeah, yes. So we will discuss about
physical.
such a fragmentation issues.
Yeah.
But this one is for physical part.
Yeah, no
okay.
physics.
Yeah. So this can be illegally touched, or that is called a scratch. Most of case, not 100%, most of case is a scratch part. So I heard that from one of my colleague friend who works for the banking industry. The bank, the database, has the 7 or 8 copies of the site, remote site. Okay? And what his main job is, every morning he checked whether there is any damaged hard disk drive. He said always, every morning he can find 1 or 2 the damaged one. It's a user. Okay? Then what he's doing is remotely ask the operator to replace, because his system has 7 or 8 copies or mirrored site. It doesn't matter, okay, whether 1 or 2 the damaged hard disk drive. That means the mechanic is not the 100% reliable. So it may be damaged easily. So this is a hard disk drive. Also, the main issue of such a hard disk drive is slower comparing to the speed of bus, speed of memory, speed of the CPU, other component of the architecture of the computer system. This is much way slower. So people think about, can we use the memory as the memory is a primary storage. This is a secondary storage. This is one of the questions, right? In the meta-museum. The people believe the hard disk drive is a primary storage. No. The CPU does not know. It doesn't like the hard disk drive or this one. Instead, the memory only get the data from the memory. Even though you request the data from a file, the information selected, accessed by the disk controller, and then returned to where? Memory first. Okay? Then the CPU read the data from the memory always. So why don't you use the memory as the storage? That is called the solid state disk. So nowadays they are competing each other. Solid state disk, not like this one, it has some memory. But the main problem of the memory is expensive,
smaller, and very expensive.
volatile, which
Yeah.
means that you lose the data without power.
Correct.
So there are different types of the memory, which is called the NAND, N-A-N-D type. The memory, it still keeps the data, even though you lose, you do not have the, but that doesn't mean it's really the forever, the certain, the theoretically, but you may not use such a, like 100 years of data. So practically, it will not use the data, so then we have the memory. Benefit? We don't need such a the latency, delay of the time. No mechanical, so no in terms of hardware, no damage of that. So it's almost zero latency, almost the zero latency. Main problem? Money. It's much expensive. It was a couple of years ago. The gigabyte is the dollar. How much is nowadays the solid state disk? So much cheaper nowadays.
Yeah.
Okay, 100 gig is less than the 100 bucks, 20, 30. I'm not sure. Recently I didn't purchase. So, but it's much cheaper and cheaper. Another problem is size-wise, this one is much bigger, but this one also getting bigger and bigger. That's when I didn't check this year, but the last year when I checked it, the Samsung actually released the commercial version of the terabyte size of the SSD. Okay, so I thought, so one year, actually I get rid of all of the hard disk drive, the information from my lecture, then talk about the SSD first, SSD only. But realize that still some of the laptops still use the hard disk drive here. We don't need such an expensive, but the latency is not a problem of this one. Because of a network, because of application level, the bottleneck happened at the other place. So no benefit. We cannot get the whole entire benefit of using the SSD. So why not going back to the hard disk drive? So still, hard disk drive is competing with the solid state disk, considering the price and the performance is getting better. So industry, they do not throw away the hard disk drive. Even though the memory, the industry is still hot, but we keep the. So we are going to see the both hard, not details because this is not the computer architecture class, not electrical engineering. But if you are in the computer engineering and the electrical engineering, also interested in the computer architecture, think about this one. Then a lot of students actually hired for the memory industry, like the Samsung and the Hynix and so on, but still the hard disk drive, I believe they will be. Still we use the hard disk drive for the disk array in the industry, okay? So disk array means, this is an old first commercial disk drive. They shipped like that. Actually, when I was the administrator, it was the 1995, I think. I'm from the South Korea. At that time, the company, bank, was the first company who purchased the disk array. So disk array from the EMC. Disk array means, so if we have the hard disk drive, one hard disk drive, why don't we make the array of the hard disk drive? Array of the hard disk drive. Also for the performance, we keep the memory on the array. So this is a disk storage like this one. Okay. Then at that time, so 1995, we purchased a disk array. First time in my country. It cost the 3 times of my yearly salary at that time. 3 or 4 times of yearly salary, but the size capacity was 72 gigabyte. But 72 gigabyte we cannot use fully because the mirroring was required. So capacity is 36 gigabyte, 3 times of my yearly salary. Then, surprisingly, so we shipped such a disk storage. It's really big. It's like I think the 3 times of rack, the general rack system. So then, actually we asked the policeman to convoy, because and also we rent the anti-vibration the truck like that. Yeah. So you can actually order going to the UPS or the FedEx. Yeah. They have such a specialized truck if you want to anti the vibration. So we actually rent such a thing convoy, and then finally we install such a. It's only 36 gigabyte. And but it happened. But nowadays nobody uses the 36 gigabyte on the laptop even. So it's at least half terabyte. Okay, like this. So this is a comparison just for the general idea of the mass storage. The operating system has 2 types. First, hard disk drive, and I'm not going to explain the details of this one. You probably know. Or one thing you can keep your mind. One, there are big latency of the hard disk. One is rotational latency to find the data, and another one is the seeking time, the latency. The 2 latency, moving forward and backward and rotation. Okay. So that is access latency is the average access time. Average seek time is this one, and the average latency is rotational latency. Okay, we will see more details later. But nowadays we have the solid state disk. Next class I will introduce more details, the comparison between the solid state, considering the hard disk drive. Okay, but in general this is much faster and reliable, but expensive still. Okay? Magnetic tape is the actual tape is still used for the backup purpose. So if you there are a lot of the backup device. So one of them I have seen. The biggest one is kind of drum. The drum, at least 5 people actually inside such a backup drum. It's like the cylinder, and in the middle there's axle that has the arm. So all around the 360 degree, there are the tape, like the apartment complex style the tape. So, and this one rotate, then pick up this, then there is a rider, the 10 to 12 rider, and put into then the right backup, like that. So this is the magnetic tape still used for the backup purpose. Okay, then okay, so I'm going to stop to explain more details. There are a lot of funny and the interesting stories, such a hardware part. So if you are interested to know more about such a thing, read the article or not just the Wikipedia. There are a lot of the things behind such a story. So based on that, what we are interested in is we are going to use the hard disk drive or SSD as the secondary storage. It's a mass storage. Okay, to keep the bigger and bigger data. I introduced the importance of nowadays the size of data. It's a big data, so we cannot keep such all the data in the memory. So definitely we need to consider something different. The data structure to keep the big data. So our operating system should support. So if you already took the big data course, or if you are taking the similar related course, what is the solution of the big data? In 1 word, 2 words. What is the idea of the solution, such a big data, like the Hadoop? What? HDFS, right? What is the HDFS? File system. It's a distributed file system. Is this solution? So, what is a file system, by the way? It's a software. It's like the program, like any other program. Software program for what? managing a number of files. We already talked about what is a file. File is a data structure to keep the information, data, but depending on the types of the file, it can be various. But we have a number of files, so it's not easy to manage. So we need a software to manage such a file, that is the file system. So file system basically consists of two parts. One is file, define the file structure. Then directory. When we have a number of the files, it's not easy, so grouping is a directory structure. That is the file system software, file system. What kind of file system do you know? Any file system. Windows, NTF, FAT, 16, 32, NTFS, or the Unix file system, and the GFS, ext 2, 3, 4, 8, 16, so such a ext, the family, the file system. Also, network-based files, NFS, there are many, the different file system. Okay, then, such a file system to handle the big data, one system is not the big enough. So we are going to consider the number of computer systems, which is called cluster system. So using cluster system, idea of handling such a big data is why don't we provide distributed file system. So that's the main idea of to handle big data. So this is the idea of the big data. So the second project, you will implement such a file system. How can I do that? You can do that. So file system itself is a software to manage number of files. That's it. Okay. Then in your project description is a detail. After we cover certain amount of lecture, then the GA will introduce more detail about the requirement. So your goal of the second project to implement a file system, but it's a portable file system. Exactly 99% same concept of the Hadoop distributed file system, but it's not distributed. So if you already use the Hadoop, you may have the concept what you guys need to do in the second project. So in this the chapter 10 through the 13, 10 through 14, we are going to mainly talk about how can we make the format structure for such a file system and I/O devices. Okay, so let's go back to this hardware. In terms of hardware, this one has the number of cylinder and the sector. What about this one? Memory. Memory has, if you remember the basic architecture of the computer system that I introduced, memory is addressing. It has number of address, sequence of address. This one has the address, and this one has the cylinder and sector. The problem, we are not going to use a directory for this one. Instead, we should have a certain data structure, like the certain fixed size of the block. Same thing on the memory. 1, 2, 3, 4, 5, 6. Certain logical block address. Logical block address, LBA. So first, low level. What row level? So it doesn't matter. The row level, we have defined one-dimensional array of logical block. That block, whenever you see the block in operating system or computer system, what's the meaning of a block? Always consistent.
It's like a piece. It's like
Piece of what?
It's like you take data and split it into an even piece.
Take data means read and write.
Yeah.
I/O unit. It's a network, same thing. And computer architecture, same thing. Operating system, database. Whenever we see the block means very, very basic I/O unit. So this logical block, actually is the reason why we call the logical block is it's not hardware part, but very low level, the logical, the data structure. First level of the data structure is the logical block addressing. So when you purchase the new hard disk drive or SSD, have you ever installed the program? No, probably not. But actually, hardware itself doesn't have any data structure. So you need to install the program that can interpret the hardware level and your operating system level, which is called a device program. Okay? Using device program, so operating system can understand how your hardware is organized and so on. Then the next step is you need to format your data. Nowadays it's pre-formatted. Most of them are pre-formatted.
Yeah.
However, when I purchased a long time ago, I need to install the device program. Next thing is I need to format. So everybody knows, so from time to time you format the memory stick and the hard disk drive. You can do that. What's the meaning of formatting? Does it change any the physical architecture of this one? No.
No.
The physical architecture is as it is, but this the logical level, the data structure will be changing depending on the format, types of format. It may use the different size or different the way of organizing such a logic. That is a logical block. It's the first low level of the format. But when you format using your operating system like the NTFS format or ext format, that doesn't actually change this one. This is a really low level. So almost similar as a hardware. So this logical, the block level formatting is the manufacturer level. Manufacturer level formatting is the cold format, or the sometimes called the row level formatting. So row level formatting means it's actually we organize all the logical block address. However, when you are doing formatting, so there are different types of format. If we are using operating quick format actually change header information. Full format, even that doesn't change this one on top of this and their own, we will discuss later, their own data structure. So even though you do the full formatting, your data will not be erased, will not be deleted. Still, there exists. So that can be used for the policeman. So if you have something illegal data, download data, so the digital forensics, so they actually, the low level access the data, then whether they have the illegal download file or not. So this is a low level formatting. So if you want to format this LBA, logical block addressing, you need to use the program provided by the manufacturer. Okay? So that is, so for example, if you get married, so you want to delete all the photo with the ex-boyfriend or ex-girlfriend, you need to do the low-level formatting, okay? Manufacturer level. Even though you format using the operating system format, maybe chance to recover, restore, okay? There are actually the 100,000 of the service from the internet. If you type the restore, recover, damage the hard disk drive, they are using this one. So, and also I had a couple of times experience to use this. Later I will introduce later. So first thing you need to keep is we have the logical block addressing, logical block address. Then after this, it doesn't matter whether we use the hard disk drive, whether we use the SSD. Okay, so the file system will be based on this. Then this device, whatever this one, will be connected to the what? This controller. If you remember, the basic computer architecture is we can consider any types of the computer device, CPU, memory, others, monitor, touchpad, the mouse, the hard disk drive, anything. We can regard this computer device as what? I/O device. It's always input and output. So, and one more thing is, from the CPU, computer architecture point of view, each and every device, this one has different format. This one has different, this one has different, and mouse has different, touchpad has different. Each device has their own standard input and output. So it's some of them are standardized by ISO, some of them are standardized I2P format, some of them are standardized. So for example, if we have the new generation of the network, like the 5G, 5G is not standardized yet because the industry and the academia, they get together, make the consortium, then there are two groups of the consortium. They are fighting each other. They try to make their standard as the global standard, something like that. Once the standardized is that, we can use that standard. However, each one has a different one. So who can understand such a different? This disk controller. So any device, any I/O device on your computer system should be connected to the disk controller. So this disk controller is especially for our hard disk drive and SSD. It's called the disk attachment. There are different types of the disk attachment. Like the Cpsc is one of them, and we have I will introduce later. Maybe next class, the example of that. Then by combining several disk array, so it will be eventually storage array. Okay, so storage array is like the as name implies, is an array of the disk storage. Is the massive storage, mass storage. Then mostly they focus on the reliability and the speed. For the reliability, the mirroring is required. The mirroring means we have the two sets of exactly same data. One is being used, another one is a standby. In case one of them is failed, we can take over the job to the standby, then we can support the service without stop. That is a mirroring. Problem? Only half the 50% utilization. But nowadays it's getting cheaper. It's not a big deal to buy such a storage. Then, plus, so this will be connected to the finally computer system. Then, this one is connected as the local bus. Okay? So there might be no problem in terms of speed. However, if we use a disk array and connect it to the computer using fiber channel, it's almost the same speed as the burst speed. So which means we can actually put the hard disk drive, the disk array storage in the remote side and connect to the computer, even number of computer, it will be eventually the same, the storage area network. So you have heard about where's my, yes. You heard about something, LAN, local area network, WAN, the wide area network. This is another one you need to keep your mind for your future. It's the same, storage area network. So we can put the storage array remotely, like the network, then configure such a connection to a number of servers. So it's many-to-many, the architecture. It's not dedicated, unlike your laptop. Then we can set up the storage area network. So nowadays, most of the computing environment use the storage area network, including the virtual environment. And the next class, I will introduce a little bit more details. Do we have the exercise left Wednesday? Okay, so why don't you bring your laptop? First, I'm going to finish this part, then continue for the next exercise one. Okay. And then one more time, so keep in mind that if you want to make up your midterm exam, you can implement the last question regarding to the real time, the scheduling. Then the GA will announce the demonstrate date, and the due date is by the Friday. So you can demonstrate, then you can get the point that will be added to your midterm score. Okay, which means it's B. In addition to your curve score, but you will get the additional point to make up. Okay. Thank you, and we will see you Wednesday.